Hi everyone. In this part of the video, I'm going to show you how to divide complex numbers. Now, when we say dividing, we're not dividing in the typical sense that 6 divided by 2 equals 3. We have a really concrete answer that we can formulate as a decimal or a fraction. Complex numbers don't really work well that way. We have to use what's called the conjugate. Now, in the previous video, I showed you what the standard form was, a plus bi. And its conjugate would be its sort of counterpart, its opposite, a minus bi. Now, there is a bunch of ways to do the conjugate, but it's always better to switch the sign of the imaginary part, the minus b, if you notice that right there. Okay, and so why we do this is because when I actually multiply a plus bi times a minus bi, I get a really specific outcome. A times a is a squared. A times b is minus abi. I know, kind of annoying, isn't it? And if I do this, a plus abi, and here we get minus bi squared, b squared, I squared. And you should be looking at this like, this is super confusing, but there's some good things that happen here. First, the abis go away, and if you remember, the I squared becomes just a times -1. So if I actually take that into account, I end up with this, a squared plus b squared, which is super nice because we now have a way to get rid of the imaginary number from anything. So let me show you how this is going to work. In my first example here, I'm going to multiply by its conjugate. So I have positive I here, so we'll multiply by negative I. Now technically you don't need to multiply by negative I here, but just for the sake of getting used to the conjugate, that's why I'm going to use this. So in the numerator, I get negative 5i. Remember, multiplication is just normal. And in the denominator, I get negative I squared, which is really straightforward because if you remember, I squared is -1, and negative 1 is just 1 in the denominator. So I'm left with this answer, negative 5i. Now, a little bit more of a standard problem here. 3 divided by 1 plus 4i, I'm going to multiply by 1 minus 4i in the top and bottom. And now I can distribute in the numerator. So I get 3 minus 12i. And in the denominator, I get 1 minus 4i plus 4i. And 4 times 4 would be 16i squared. And this is where that payoff comes in that I talked about earlier. Look at that. Gone. I love that. And this will just become plus 16. So my answer is 3 minus 12i divided by 1 plus 16 is 17. If I could reduce, I would, but this is 17 is a prime number, so I cannot reduce. In our last example, you might look at this, and you notice that the I and the real and the imaginary part have been switched in my denominator. So what I'm going to do is I'm going to switch them back to plus 3i, making sure that my signs line up appropriately still positive 3 and positive 2, just because I think that's a little bit easier for me. And like I said, I like to switch my conjugates. So when I do my distributing, the top part's going to be distributed as well. So this is -4. This is plus 6i. This is plus 6i again. And this one here will get me minus 9i squared. My denominator, now that we've seen this, you might be able to do the shortcut. You might want to try it and see if you can see what's a squared and b squared. So 2 times 2 is 4. 2 times 3 is minus 6i. This is plus 6i. Whoops, 6i. And plus 3i minus 3i gets me negative 9i squared. So very similar top and bottom, if you notice. Two things. One, the i's cancel down here, and this becomes plus 9. So if you tried doing it mentally, 4 plus 9 would have been my denominator, so 13. And up top, again, this I squared becomes a plus. So I have -4 plus 9, which is positive 5. And 6 and 6 gets me 12i here. So that would be, again, I can't simplify this, but if I could, I would. So that is the process of dividing. I know it's a little bit more complex. We're not really dividing, we're really multiplying by the conjugate. So that's how we simplify. It may be a better way to say it. All right, I hope that was helpful. There's some problems in the next one to try. And let me know if you have questions.